1. Bam, and here we are live. Today I have a really special episode with my special guest Patryk. This is an offline podcast actually. This is the first time we are making it offline, so I think it will be great, right Patryk?
Yeah, sure.
We ate amazing pasta. How was it? I cooked it myself.
Yeah, it was great. Yeah, the salad.
And the salad, there was a small salad.
Yeah.
That was a surprise. So basically, let me make the small introduction. Patryk is actually a Rust developer, a really skillful developer. I asked him, actually joining the podcast when? I believe 1 year ago, right?
Yeah, something like that. Yeah, it was a long time idea.
Long time idea, this podcast. And when I see Patryk, I knew that was the guy to ask for the podcast. So as I said, Patryk is a really skillful Rust developer. And he's making actually a lot of system programming and crazy projects. We will talk about them. Maybe before all, I explain for the first time how we met. We met in Wrocław Rust meeting.
Yeah, it was a meeting of the Rust Wrocław,
Yes.
Rust Wrocław group. So I think we met on like a break before two talks.
Yes. I catch Patryk while eating some stuff. You know, back then he had long hairs, not like this one.
Oh yeah, I forgot about my face. Yeah.
Yes. He had like huge hairs like this. He had a really big beard, just like today.
Yeah.
And I know that guy writes Rust. And yeah, we talked and yeah. So let's start with it actually. How is the community work is going?
Yeah, so that's pretty nice. I've actually finally convinced myself to try to host Rust Wrocław at not my company, but the company I work for. We had our second meeting there on the Thursday. So I think it went pretty well. It's obviously always a bit stressful to organize stuff because I was both organizing it and then talking there. So it's always, a bit stressful, but I think it went pretty well.
And you did like how many times the talks? You did a lot, right?
Yeah, I think it was like 6 times so far.
Damn, that's
a lot
cool.
of talk about, lot of stuff to talk about.
Wow, that's really cool actually. What was your last talk about?
So I started a small series called Wait Why, and I had my second part on that Thursday, and I'm talking basically about stuff that seems contradictory or difficult in Rust on the surface. So like some obscure error messages you might find, and I'm explaining them. So that's stuff that it's not like imagined stuff or stuff you will not have to deal with in reality. It's stuff that I actually stumbled upon at some time in the past. I wrote it down that it happened, and then I talk about it.
Amazing.
So from practice.
So it's like a video blog post.
Yeah, it's like a video blog post, yeah.
And by the way, those videos are actually recorded, right?
Yep, it's on the Rust Wrocław channel, so you can probably
Rust,
link it somewhere.
Wrocław, YouTube, just go for it. You will find Patryk.
Yeah. And obviously tons of other speakers.
Yeah, also tons of other speakers. Yeah, I've been there actually a few times. It's a really friendly community. I really like it, to be honest. Yeah. So let's talk about actually the Rust. How did you... It's a quite rare technology. How did you first encounter and what actually bring you to Rust?
Yeah, so what brought me was that I... at one point, like must have been 5 years ago, I wanted to do meteor station that would show me what's the weather like now. And I had the Raspberry Pi and an LCD screen for it.
Yes.
And I was looking for technology that would allow me to display something on the screen. And I remember I looked into both Go and Rust, and actually I've checked out Go first. I really liked some of the stuff, like for instance, you can do JSON serialization natively in Go, so like natively as in in the standard library, so we have it built in, so that's nice. Unfortunately, eventually I did not fall in love with Go because of I think the type system was mostly like nailed to the coffin, so like I felt like it was not expressive enough for me. Then I tried out Rust. It wasn't love at first sight either.
Yes.
I think I had like 4 approaches to Rust. So I was like trying something, then I gave up, something else, gave up, giving up, trying out.
Nice.
And finally, with this fourth project, this fourth time with this project, it clicked in. And I realized that it's pretty good language.
Amazing. By the way, I actually did the same challenge you did. I also tried Go and Rust, and I'm right now going with Go. Yeah, but that actually surprised me. What do you mean by the type system was loose? You said nailed to the coffin. Why it was like this?
So, for instance, there's this kind of idiom in Go when if you have a function that returns an error, then inside when you call this function, so sort of the outside, you have to do if this function return error, then return propagate this error.
Yes.
And I think Rust approaches this problem much more nicely because you can just use the question mark operator. And I think also the approach to designing stuff with Go interfaces is really kind of, I think it's novel, but I think it doesn't click with me. So I think it's kind of weird, frankly, that for a type to implement an interface, it has to have function with matching name and matching type parameters. Well, not type parameters, but types in the.
So you mean the interfaces, right?
Yeah, about interfaces.
Yeah.
So it's like being kind of implicit in Go's side. So you implement an interface by providing it everything it needs, versus being explicit in Rust when you write impl something for something else, and then you have to implement everything listed in there.
Yeah.
I do realize both have approaches and pros and cons, but I think the Rust approach resonates with me better.
Nice, really nice. To be honest, I'm a huge fan of Go's interface system. And the thing I really maybe don't like that much is in Go, in order to have a class as an attribute of a class, they call it struct. You need to embed it. And after the embedding, you can use all the functions of this. Basically, there is no hierarchy in Go. In Rust neither. In Rust there isn't also the classes, right?
Yep. You don't have classes. So I was coming from PHP. So before starting with Rust, I was doing some PHP professional programming and using classes. And also abstract class extends, whatever was the typical way to approach modeling your domain. And now I think that it's the worst way. So having written some Rust, I think the Rust approach is much more clear with your intent.
Yes.
It's kind of difficult to explain because it's like this feeling in your head that you understand the Rust approach better when you understand it.
Yes.
So, but yeah, it took me a while to understand that Rust traits are not substitute for classes; they are just something else.
Yeah, it's really tough though.
Yeah.
In Go, the thing I love the most is when you actually clicked to a standard library method, or also outside of third-party library also possible, you actually go to that page and everything is so clear you cannot believe. If this is some sort of interface, it directly gives you what attributes you need to give it to make it work. And bam, easy as that. But in Go, I also really like when you create a variable, it comes with defaults. I think it's such a perfect idea. It just stops so many errors to come. Like you initialize an int, the value is 0. You initialize a string, the value is empty string. It goes like this. And I really love that one. And I have to say, my biggest love point was this asynchronous, actually, the concurrency model.
Go routines.
Go routines. I know that you guys are also in Rust using fibers.
Actually, those are not fibers. So
maybe just a second. Maybe let the other people know, because maybe some people do not actually know about that. Basically, in traditional programming languages, let's say Java, C#, C++, multi-threading is working on the below operating system. So I believe in the CPU level, it is working, multi-threading. And actually switching from one thread to another costs significant amount of time and energy. Therefore, even though when you make multi-threading, it is taking too much resources to actually, and it waits too much for your program to actually work. So Go and Rust, I know Rust is also doing this, are using this fiber method, so not multi-threading but multi-fibering. Basically, the program itself controls when a thread, hashtag like fiber/fiber, actually needs to start and when it needs to stop. With that, with just avoiding changing the threads, it is saving so much time and resources. So it's all handled inside the program's runtime. Programming language controls when it needs to stop and when it needs to go. So yeah.
Although in Rust case, those are actually not fibers. Rust used to have fibers, I think, before 1.0. And what Go and Rust do differently is the difference between cooperative multitasking and preemptive multitasking. So the difference is that, let's imagine we have like 100 functions we want to run at the same time. So what Go does is called preemptive multitasking, and is that, like you said, the scheduling or switching of which of those procedures gets to run now, because you cannot run actually 100 of them at the same time because you only have so much threads on your CPU.
Yes.
So the switching happens inside the program. So it decides that, this function has been running for 1 millisecond, let's say, just guessing. And now it's time to let the other function go.
Yes.
And instead of kernel doing that, it's the application which does that. And because it's happening in the application...
Yeah, but is it happening in Go or is it happening in Rust?
It's happening in Go. And it's called preemptive because you're forcefully finishing execution of one function to start with another function. And what Rust does is called cooperative multitasking. So the asynchronous, async fn stuff in Rust. And the difference is that with asynchronous functions, you have to, when an async function is running for a long time without calling await inside of it, the Rust does not have a runtime, so it cannot physically stop the function from running.
Rust does not have a runtime?
No, there's no runtime.
What?
That's why Rust also works on microcontrollers, right?
What?
So because microcontrollers have only not so much of RAM and stuff, you wouldn't fit, runtime in there anyway.
Okay, let's get back to this point.
Yeah. So about the async fn. So the difference is that in Go, the runtime at some intervals of time stops executing one function and switches it for another. And it does it all the time. It switches constantly. In Rust, the function at one point decides that I'm finished, I'm waiting for something, and gives the control back to the Tokyo runtime, for instance, so that it can pick another feature to run. And it might seem like a small difference, but it's actually a pretty huge one, because if we, for instance, imagine like a loop in Go, when you have a loop that let's say it's infinite, so it just does something constantly.
But the compiler understands it. If there will be starvation or deadlock, it understands. It doesn't run infinitely.
So let's just say a very long loop, I don't know, needs a second to finish some computation. So in Go, you can still use such a function in Go routine, because the runtime will still do this interval switches inside the loop. While in Rust, if you have some async fn that runs for a long time, which doesn't do awaiting inside of it, it will actually continue running up to the point it decides, I'm finished. And like I said, it feels like a weird thing to do for Rust. It feels like the worst, in a way, the worst thing to do here, because it's less useful.
Yes.
But because the async functions in Rust say when they want to give up the control, say that I'm finished, I'm waiting for some data from socket, I'm waiting for a file system to do something. Because they decide those await points on their own, you don't need to have a runtime. So the way it works is that the Tokyo,
But just 1 second, because most people, I believe, that listens this will not have that many Rust experience, so we may be a bit lost here. So basically, the idea is, as far as I understand, in Rust, inside the loop, let's say we are awaiting for a lot of things. Let's say there's a loop 0 to 1000, and inside the loop, we are making 1000 database connection. I mean, that's a stupid thing to do, but let's say we do it. And in that case, what you say is Rust waits until the loop ends.
Also, if you await inside the loop, then it's
Yes.
all right. But if we say that, let's have a loop that does some computation for a second, some actual math that you cannot await inside.
Okay.
Just some complex stuff that it waits to complete.
Let's say we have some computational task which needs to be awaited, but we don't await. Then what happens?
So if you like have some function that's asynchronous, but you don't await it, then the function is not actually run. So this is contrary to, say, JavaScript, because in JavaScript you can, when you run an asynchronous function, it just starts running in the background, and then awaiting is kind of optional. You can, but you don't have to.
Yes.
I mean, if you don't wait, then you won't get the result, but the future of the promise will complete working in the background.
Yes.
But in Rust, if you don't await, then the future stops working. It's just not executed or not executed anymore if you don't drop it in the meantime.
Interesting. Really interesting. So you have to await for each one of those.
Yes. If you want to get the result, or if you want to, for the future, to keep running, you have to await it.
Yeah. And what about this not runtime? Like, this is the first time I'm hearing this. A programming language doesn't have a runtime. In C++, how it works?
You also don't have runtime there.
What?
I mean, there's...
So what's happening in runtime, actually? What is the advantage of runtime?
So the advantage of runtime is that you have some kind of like a framework or a wrapper for your application that can provide some extra stuff. For instance, in C# you have runtime, and what this runtime does is that it takes care, for instance, for garbage collection.
Yeah, that's what first thing come to my mind.
So allocate, and then the runtime takes care of releasing the memory for that. Not sure about Go, but in Rust, for instance, if you...
Yeah, garbage collection also does in Go.
There's also garbage collector, alright, yeah. So that's what the runtime gives you. And this is like a pro. And the con of the
runtime.
Yeah, the con of the runtime is that...
RAM. Memory.
Also, but it also makes it difficult to, for instance, invoke a library from within your application. So, for instance, when you have like external libraries, so you have your application, and your application can call other Go code directly if you're writing it Go, but you can also invoke like some library written in another language.
Yes.
That just provides, encompasses some one particular thing, let's say audio system, and then gives you some functions to call it. And it's easy from within C, C++, or Rust, because you can just actually invoke the function you are interested in, so play sound, whatever, from this external library. But it's much more difficult in Go, because you have to take care of the runtime. And for instance, what this means in practice is that when you're running this external function, the preemption doesn't work. So you can say, if you call some external function from a library, not written in Go...
I understand now. So garbage collector is not able to actually delocate the memory. Is that correct?
Yes. At least when the external function is working, it needs to wait when the controller gets back to your Go code.
And it never knows when it will actually stop working, right?
Yep. So you can easily get in trouble if you have 12 cores on your CPU, and you run on 12 separate threads, some separate libraries, you can actually get your application deadlocked. So prevent the garbage collector from working, and prevent Go routines from working, because they all need this runtime.
Yeah, but probably it wouldn't end up with that login, at least in Golang. I'm not sure about the other ones. But yeah, actually, the thing you said is pretty correct. But let's say this library also adds to runtime. So we have a huge, let's say, class. Like, even a huge class, how many kilobytes it can be, right? It probably is nothing.
When you have, like, external library?
Yeah.
Okay, so from this point, usually when you have an external library, the concept of classes does not exist anymore. So when you have like some external library, usually what you get is just a set of functions. You don't have any classes, any
But depends.
types.
Some of them comes with the classes, and you create an instance and go on.
So then you are talking about separate Go code or separate Rust code from within the same programming language. So
Yes,
yes, but you can have libraries already compiled to to machine code that you can then use in your application.
Yeah.
And then only thing you have is the API of this library, not its code. You only get the compiled version.
I get it. Probably I thought about JavaScript, because in JavaScript, the code actually stands in node modules, and you can actually even go to the node modules and make some changes, but probably they will end up with compiling just before starting the runtime. So library and the normal code just compiles one binary, and that one is running.
Yeah. So in JavaScript it's a bit different because technically you don't have machine code at any point. You always have some JavaScript code. It can be in different directory or somewhat hidden from you, but there's still JavaScript code at the end of the day. But in Go and Rust and C++, you can link code written in any other language you want.
Yeah.
And you do not get the original source code. You just get the compiled, artifact, the binary. Yeah.
Small version. Yeah.
Yeah.
Yeah, really interesting. And by the way, when I find out, I know somewhat about Rust because I finished this amazing book, Rust the book.
Yeah.
The book is perfect. And also there were these exercises, the Rust links. I also finished those ones. So I have a general understanding, let's say, about the Rust. The thing that surprised me the first was actually in Rust there are multiple asynchronous concurrency models, and they are controlled by community actually as third-party libraries. So if you want to use some async code, you install the crate. In Rust, library is called crates. Crate called Tokyo to your project and go for it, right?
Yeah.
And it's, I believe, it's somewhat similar to JavaScript, right? There is async await in Tokyo.
So what the Tokyo provides, or to start from the first, what Rust provides is the way to create async functions, but not to actually run them. So you can run async function in Rust, but nowhere in the standard library you will find, for instance, asynchronous functions to read a file, let's say. Those are all synchronous. And you shouldn't at least call them from the asynchronous context. And what Tokyo provides is this set of asynchronous functions for doing file system operations, for doing internet, so network operations and stuff. And Tokyo provides the asynchronous version of the Rust standard library.
Nice. And how it does that? How it converts a function to a asynchronous one?
So it's actually funny because for file system there are some projects that implement proper asynchronous versions of the how the kernel works. But actually what Tokyo does for file system is just wrapping stuff to, when you call read file, let's say in Tokyo, it just spawns another thread. So and this thread you just await until this thread completes work. So this is just a wrapper for the synchronous version. But for instance, for networking, Tokyo actually implements, or at least uses some other crate that implements proper asynchronous stream operations with the help of the kernel. Because the issue is that the asynchronous versions or maybe the synchronous versions usually work on one stream at a time, and then if you handle 100 clients, 100 stream connections, you spawn 100 threads.
Yes.
But all of those threads, each of them, work on a single connection at a time.
Yeah, but is it actually that good? Spawning that many threads?
Yeah, so because that's not really that good, here comes the asynchronous versions of the libraries. And the difference is that when inside your Rust code you await for some stream to complete, say you download a file and you wait for it until it completes. What the Tokyo does is that it collects all of the stuff that currently awaits and just sends one kernel syscall with all of the streams.
So optimizes it.
Yes. So it optimizes, because calling kernel is what takes so much time, because you need to, there's some CPU internal thingies involved, but let's just say it takes much time to go from your application back to the kernel.
Yes.
So, the less we do that, the more CPU time your application gets, which is obviously always better. And that's why, async helps, because instead of 100 threads, all calling kernel, which time costs, let's say, 100 units of time. You do it just once with information from those 100 at one time.
I understand. Well, I don't. It's a general idea. I understand.
Yeah.
Yes. Really interesting. And programming languages are for applications, to build some applications.
Yeah.
In Rust, right now there aren't that many jobs or projects because it's really new language. But what can you actually build with it? What can you build with Rust?
Mm-hmm. So it's called Systems Programming Language, which can scare some people off, but I think you can build just nowadays. You can build anything with Rust. So maybe if mobile applications are your thing, then maybe Rust isn't that much ready yet.
Yes.
AAA games. This is also not ready, but it's close. So you can build games with Rust. There's great library called Baby. That's gives you engine for creating games.
Wow. By the way, Patryk is also a game engine creator in Rust.
Yes. We've also got...
So you guys use this Baby, the one you mentioned?
Kinda. So what we've created initially was... the first game we've created was without Baby. And the engine I'm writing right now is like a plugin to Baby.
Yes.
Because what I'm doing is I'm implementing the rendering engine. So, pretty triangles on the screen.
About the project we will talk about later.
Okay.
So let's keep it right now. What we can build.
We do with Rust?
Yes.
Yeah, so, like I said, games. You can also do obviously some servers. There's at least 4 crates for creating servers. So there's many options to choose from.
So HTTP servers, right?
Mm-hmm. Yep. Or gRPC servers.
Oh.
So that's also nice. And I also created one gRPC server, so it was really pleasant experience.
Nice. I also am a huge fan of gRPC.
Yeah. So it was very pleasant because, you get the type check-in, so at compile time if something's broken.
Yes.
You can...
And when you talk about the system programming, I know about Linux kernel, but what do you mean exactly by system programming? Let's say I want to start learning system programming. What should I do? Is it how you actually manipulate operating system? Or?
So I think the name is a bit of a misnomer. So it says systems programming, but it's not about programming systems. It's for creating applications that are big. So big, yeah. So the systems programming isn't about programming systems. It's about creating systems as a kind of set of connected applications.
So it doesn't mean operating system. It means a huge system.
Yeah. So that's why it's a bit of a misnomer, because it suggests to you that you do a kernel programming in Rust, and while nowadays you can, obviously most people don't do that. Most people do write some CLI applications or some stuff for fun. Which Rust is great for.
So you say that system programming tasks, other than the CLI operations, what would be a really amazing system programming application?
Oh, that's a tough one.
I know one, probably databases, right?
Yeah, I think databases would be high on this list, because a database is not just something that accepts operations such as insert, update, or delete. Database also handles the networking, vacuuming the data to follow Postgres terminology. So keeping that the data is easily accessible on the hard drive.
Some sort of cache.
Yes, cache, or moving things around to optimize them on the hardware, on the hard drive level. So it has multiple things going on at one time.
It's so fucking interesting. I want to ask a lot of questions about this thing. So let's say I want to manipulate the RAM directly. How would I do it?
No, so that you can even do with Go, because you can just create variable allocated on the heap, and then voila, you modify it.
Yeah, but okay, let me give you another example. Let's say I want to actually manipulate the networking of that device, and I want to actually scan all the possible devices around me, and I want to communicate with them. How do I do it?
Well, so there's 2 parts to this question. So first of all, if you have a driver which already supports that, which say most Wi-Fi drivers, for instance, provide you such functionalities, And then there's the second part. So this is what happens inside your application. So you communicate with the driver to do some stuff. I think for Rust, I even saw some crates that would allow you to actually scan the neighborhood of your device.
And for example, how those crates are created? Like, how do you make a programming language actually talks with one part of the computer?
So this is where the kernel comes in. So let's say you have Linux. So Linux, so there's like a boundary. So there's your application, which is software. And then there's this boundary where you go to kernel. And kernel is like the hardware part of your stuff. So what the kernel does is that it communicates with the hardware in a way that won't break it. So this is what drivers do. They, communicate with hardware in a way that won't overheat them, in a way that validates the input data. So that the commands you send from applications actually make sense. And in this case, so the neighborhood discovery, let's say, is usually the kernel that would expose some kind of interface for your application to use. Usually this is called via syscalls. So this is called like this shortcut for system call. And what syscalls do is that they allow you to communicate with the kernel and
how can I know which syscall I have to do to communicate with that part of the kernel?
Oh, there's a list.
There's a list?
Yeah.
Probably I need to read some Linux kernel books to have that?
Yeah.
Damn, amazing. It's really amazing.
Yeah, but to be fair, because Rust is frequently associated with this, low-level kind of programming, I think I would say that Rust is more high-level than PHP to me, even, mostly due to the type system.
Yeah.
For instance, I remember back in my PHP days, I was doing some, website that was, let's say, fetching users from somewhere from the database, and I remember that there's this pattern called repository. So this is like a class that allows you to fetch stuff from the database. So we would have, for instance, user repository for fetching users. And the issue is that PHP does not have types. I mean, it has some typing nowadays, but didn't have back then. But you could put types.
It has now?
It has some minimal type system nowadays.
I didn't know that.
Yeah, you can, I think, type scalars, and you can say that you have an array.
Okay.
So you can say like string in float array. So we still step in the correct direction.
Yeah.
Yes, but the issue that I'm aiming for was that you couldn't actually say that your repository returns your array of users inside the code. You could do it inside a comment. And PHP Storm, so the IDE, I think the most popular IDE for PHP, was actually passing those comments. And if it found something like @ returns user and then square brackets, it understood it as returning users, but this was just like a comment. So your actual PHP code could be returning anything. It was not validated. Yeah. It was just like a pinky promise that
I get it. So when I learned Rust, actually when I was learning Rust, I was surprised by some stuff, some functional programming concepts, map, filter, for each.
Yeah.
Really beautiful, right? And when you actually chain them together, it doesn't come with the performance overload.
Yes, that's true.
It optimizes it, and I think it's incredible for real on the Rust.
Yeah, because I think, for instance, in JavaScript, you also have similar map filter operations, but each time you call this filter or whatever, it builds a new collection from scratch.
Yes.
So you have like 3 filters. In principle, it will, say you have 1,000 items on the input, and then each filter just does something to this 1,000 items. So the first filter will go through all of the 1,000 items, collect them to a new collection, then invoke the second filter, go through the filter collection, and you have this chain of operations that finally gets you some output collection. But in Rust, when you chain operations, they actually all work at once. So it's this,
and how it does actually, I don't understand, because it seems to me that if you have one filter, let's have an array from 0 to 10, and we have 3 chain functions. First filter, we are filtering all the multipliers of 2, all the even numbers. Then we are tripling it in a map to 3, then tripling it in another map. So we have 3 operations. And I don't understand how Rust is able to do it. Like, I may understand how Rust is doing without creating 3 different arrays. But I don't understand how Rust is doing it without 3 different operations, actually. How it does.
So in principle, the issue is that, the solution is that when you call filter or any other kind of combinator on the iterator, like you said, it does not collect stuff, so it does not build the new collection immediately.
Yes.
It's like lazy, so to say. And we can imagine it as a chain of operations. So we have like the initial collection, then filter, and the output collection.
Yes.
The issue is that you actually build the collection from the last step. So we have the collection. So we have these 10 items, and then the final collection. There's a method called next that returns you next item from the iterator.
Okay.
So if we had just the initial data and the output, then this next would be 0, next 1, next 2, next 3. Simple as that, because no filtering is in there. But with the filtering steps in between, what happens is that you call the next from the last step, then it goes through all of the steps and just either gets you an item or doesn't get you an item. So what this means is that, to have simple example, let's say that we have first step that multiplies by 2, then another so let's say also multiplies by 2 and also multiplies by 2.
Okay.
So just chain of operations. So you have this initial data from 0 to 10, and you have the output step that collects this stuff into actual arrays. So you call collect, which calls the next method, which says that goes back to the first step.
Okay.
It says I need the previous value, which I'll multiply by 2. So we go back. It says I need the previous value, which I'll multiply by 2, and we get to the initial data. It returns 0, which is like 0 multiplied by 2.
0.
Which is 0 multiplied by 2, which is 0, and then we get it back to the...
So it still makes 3 operations.
Right, unless it's optimized out, because thanks to the way it's designed, that you don't actually collect the array at each step, it's very easily optimizable. And let's say in this case, I am 100% sure that it would be virtually the same as if you just called map and multiply by 8.
Yeah. So for example, let's say we have 4 chain methods, multiply by 2, multiply by 2, multiply by 2, and a filter one that eliminates all the evens.
All would be even in this case. So.
Yes. So in an optimized case, it wouldn't make any operation.
Yep.
Then it's fucking amazing.
Yep.
Yeah, JavaScript looks really dumb actually when we look at it like this. Yeah, it's pretty incredible. And we were just staying at what can we build with system programming, and you mentioned that we are actually having these kernel system calls, and this is how it communicates with below levels. So in that case, actually making the same kernel call, you can actually write it in Node.js also, right? Or Go?
I think you can't invoke kernel calls directly from within Node.js code.
Really?
I'm not really sure right now, but I think not. Because I think in JS, so you need kernel calls for stuff like reading files from the file system, right? Because this is not something your application can do on its own.
Yeah.
So this is when you call something like read to string or read file, it eventually reaches the kernel and say to read this file and get the string back to me. And
so it doesn't allow you to directly communicate with kernel, but it wraps the kernel around. In a way, it at least wraps the communication with kernel. What you mean, right?
Yes. So what I mean is that in Rust, the standard library eventually calls the kernel directly because it's like, let's say, bare metal, so to say. But in JS or Python or Ruby or some high-level languages interpreted, so to say, is the virtual machine that provides this functionality. So in JS, if you write
to runtime,
JS, yes, so the runtime, yes. So in JS, it's like you have your application, and when it needs to read stuff from the file, it calls the runtime, and then the runtime communicates with the kernel, and you get back what you wanted. So this extra step.
You might be right. I never had to use directly the system calls myself in Node.js, so I'm not 100% sure, but I know that in order to put a running JavaScript runtime to debug mode, you actually have to make a syscall. But obviously you don't make this syscall inside Node.js, but instead you are doing it outside to Node.js. So I'm not sure actually if it allows you to make the syscalls or not. But yeah, you are right. You know, I was in a Go language meeting actually once.
Oh.
And a guy presented in Go for Wrocław community actually. And a guy presented their project. It was a database written in Go.
Wow, alright.
Wow, right?
Yeah.
I've been so surprised. Like I thought that you can only create a database in a manually memory collected language. But they did it, man. It was working.
Yeah, sounds nice.
Yeah.
Like, impressive project.
Yeah, definitely impressive project. I don't think it would be that efficient. I don't know about this thing. But probably I will go with Postgres. Yeah.
Yeah, I mean, I also had a few ideas to create my own database. I had to stash them underneath my blanket because I have so many other ideas that,
Yeah.
And this feels like a very cool project to do, but I would be also like a little worried about actually using it for, going to my colleagues in company and saying, let's use my database.
Yeah, nobody will do that.
Yeah. Because it just feels like you always will have some stuff that, let's say, your database crashes in the meantime of writing some stuff and then it doesn't get back up. So what do you do?
It's so scary.
Yeah. It's a cool project anyway, to at least know how to handle
and
those
at the same time, man, I started to have this mindset. If I will do something cool, that means my 8 months, at least, right?
Yeah.
So, to be honest, if I make such a huge investment, like in these 8 months, I am just canceling my time with my family, my girlfriend, my dog, the other stuff I can do, the other cool stuff. Because always there are cool projects, right?
Yeah, let it be worth it at least.
Yeah. So either I have to make some money or it needs to somewhat help my career. I mean, obviously making a database probably would help.
Yeah, that's always, gives you something to talk about at interviews.
Yeah, but probably, to be honest, because I'm not sure if anybody going to actually install the executable and actually try this database themselves. Yeah.
Although when I was interviewing staff, candidates for company, I have not run their code, but I did have look at the GitLabs, whatever they had provided.
Yeah.
So it always helps to provide something at least.
Yeah, obviously all candidates have to provide something, definitely. So yeah, I've been actually scared out of Rust. It is like alien programming language, man, for real. Everything is so different. And it comes with its own problems. Like, probably everybody heard about this borrow checker, right? Like you need to, there is actually a value and basically you don't copy this value. Either when the function finishes with the value, passes, or the value is done. It's going to be that. It's going to be deallocated by. So it comes with its own problems, especially when you are working with multi-threading, right?
Yes, you have to be very careful, but I would say that it not as much creates new problems as exposes problems that are already there that you might not be aware about. So let's say you have some int value that you want to, and you spawn like 10 threads, and each of those threads does value +1. So I think in Go or in C++ also it's like a valid thing to do. Maybe undefined behavior, I'm not sure, but I think you can do, and the code will pass the compiler. And this is actually a bit nonsensical thing to do, because when those threads are not synchronized in any way, then this +1 that each thread does in a very, basically at the same time, does not guarantee you what's the value going to be after, after a second, let's say. And in Rust, you can't do that. So simply, if you try to do that, the compiler will yell at you saying that you cannot actually access the same variable from multiple threads at once.
Yes.
You have to use something called an atomic variable.
Yes.
And the difference is that atomic variables, also present in C++, but not mandated by the compiler, while in Rust you have to use them in multi-threaded code. The difference is that atomic variable is fundamentally able to be modified from multiple threads at once, because when you do +1, you say to it, how should this +1 behave in regards to other threads?
So when you say atomic, probably it does this, right? Before increasing the integer, stops reading this integer or writing this integer, then you make the operation, then you open to the world that, okay, this integer is readable and writable.
Kinda. So this would be more of like a mutex.
Yeah, mutex.
The difference with atomics is that, so when you do like this value +1 in CPU, this can be 3 separate operations. So like load value from memory into register, increase the register, and then store the register back into the same memory.
Yes.
And because those are 3 operations, when many threads do them at once, it can end up that both threads start one instruction after the other. So we have first thread, it started to load the value into memory, and then we have the second thread, that when the first thread is actually doing the +1 on the register, the second thread is just loading the value from the memory. Then the first thread stores the modified register back into the memory, so it completed the +1. But the second thread, only after this instruction, stores the modified its register. And the difference is that both threads have executed +1, but if the initial value was 10, then after those 2 threads complete, the value is 11 instead of 12.
I get it. Because
there's a step in between.
I get it. So because of its completely closes until it does, the first one, the second one that's trying to intervene isn't completely going to be passed, and the third one, I believe, will increase that value.
Kinda. So the issue is that if you have three steps required for actually performing +1, then if first thread is in the middle of performing +1,
yes.
So it has this register stored already with, let's say, register equals 10. Right?
Okay.
Then it performs register +1.
Okay.
And then it performs store register into memory.
Okay.
And if we go back, so we are at the step of register +1. Then the second thread comes in. It just loads, so it performs the first step. It loads the value from memory.
Bam, blocked. No, it's already used in another thread. You cannot do that.
No, it's not possible to do that, actually. No, none. At least none of the CPUs I know work this way.
Okay.
So on the CPU level, this is allowed thing to do. Just like one of those values will be stored.
So thread is already reading. The second thread is already reading.
Yep.
Then what?
Yep. Then we have like third instruction. So the thread number 1 has register equal of 11. It stores the 11 back into memory. And the second thread, it already loaded the value in the previous step. So it does not know that the value has changed.
Yes.
So it thinks the value is still 10, performs value +1, so 11, and also stores 11 into the memory.
Bam, we had 2 increase operation, but it increased just once. So you say that in other languages there are this kind of problem, and in order for Rust to solve it, it needs to give to the other thread the value itself. So there will be always one value.
Yes, so that is one of the solutions.
Yes.
Or you can use atomics, and atomics work used CPU to help to perform this operation atomically, so at one time. So if you increase in typical integer is 3 instructions: load, increase, store. Then with atomic you have one instruction like load, increase, store.
Nice.
Like single CPU instruction.
So nobody can read it.
Yes, there is no in between step.
Nice. But Go is solving it, I think, more purely.
Yeah.
These channels, you use them?
Oh yeah, I know what channels are.
It's incredible, man. It's incredible. Like, I can talk about them all day. Like, instead of just blocking the memory, it's able to communicate through this memory, so nobody can actually touch it. And it's such a pure solution to this problem.
Yeah. I remember when I was doing some multi-threading back in Pascal.
Oh,
so like my first language.
You use Pascal?
Yeah. Like when I started like 10 years ago. So I started with Pascal actually. And I was doing some application that generates mosaic images.
What?
So like you provided like a directory of like memes, PNGs, JPGs, whatever.
And it was censoring.
Yes, and it was scanning those, understanding their like what's the average color of each of this chunk image, and then you provided like the main image that you wanted to build out of those chunks.
Incredible project for real.
Yes, it was very nice to code. Also learned a lot about color systems and stuff. So this is a very cool project, and I wanted to make it multi-threaded because it took a while to discover when you have this pixel which chunk to use from this directory.
Yeah, this is a perfect idea actually to move to threading.
Yes, and it was difficult to do in Pascal because there's no channels. There's no, maybe nowadays there are, but 10 years ago there weren't. And there's no concept of Go routine, so
But then, that means that you were actually a pretty good developer when you were 16, right?
Yes, I think I started when I was like 10 or stuff.
Wow, incredible.
Yes.
You're born into it almost.
It looks this way, yeah.
When I was 10, I was playing Wolf Team and eating chips. Oh man, I wasted my childhood.
No, to be fair, I sometimes think I should have just stayed more outside. So,
really?
Yeah.
Oh, so
Take
it, Patryk. I did that. Yeah, maybe I stayed at home. I don't know what I did. Yeah, I read some books back then. Yeah.
Yeah, that's also nice.
That's something.
Yeah.
Yeah. Really cool. So maybe let's make a small break and drink some tea and talk about your project.
A little longer than a few minutes later.
Here we go with the part 2. So we made a small... Okay, I guess it starts recording again. Here we go with the part 2. So we gave a small break. Just chit-chat about it. Damn, didn't I close the slides?
I thought so, yeah.
What the fuck? Is it opening itself? Look, I'm closing. If it opens, we will find out.
Yeah.
Okay. So, in this part, we will mostly talk about Patryk's projects. He has incredible projects. And about how to find a job, actually, as a Rust developer. Because I've been employed as a TypeScript developer so far. In web development, there is some sort of pattern to find a job. And it's actually quite logical, meaningful one. You first, if you are going to apply for full stack role, you are going to build some web applications, basically. You will use different technologies, some different SQLs, different frameworks, and you will build some projects, put them to GitHub, make a portfolio, and go apply with your CV.
Yeah.
And for system programming languages, it always confuses me actually how you actually do it. So how do you do it?
To create. Yeah, so in my case, I think I kind of get lucky because I had a few projects when I was applying to NXR. One of those was this Meteor station I was looking at the beginning. It was not very fancy. It was maybe thousands of lines of code, but it was nice because there was some, icons. You can show it out. It was showing time. There was even some, I think, integration with Early, maybe, or some other service that provided data about weather. So Early, in this case, provides data about, air pollution. So I think it was some other open weather, whatever, some API, for weather data. I think I also had a small game, terminal game. But yeah, now that you mention it, I think it's difficult because with PHP, let's say, or JavaScript, it's easy.
Yes.
Because there's just one specific type of application you're writing in those.
Maybe not easy, but well known.
Oh, yeah. Easy as in easy to find out what to do, at least.
Yes. It's because there is also challenge in that part because of there are more actually opponents. Rivalry is a bit higher, I believe, and the actual requirements of candidates is growing. Keep getting larger and larger. When I find the job, I knew already TypeScript, I knew Node.js, I knew making backend with Node.js using Express, making the front end, different SQLs. So all of them, And 10 years ago, I don't think so. I don't think they actually look for that many stuff.
Yeah, I think it's a common sentiment that it used to be easier to find
Yeah.
jobs, mostly because there weren't even that many frameworks to start with. So
Yeah.
even if you knew language, you could get pulled from the street basically.
Exactly. Yeah. So, for example, let's say, and there aren't that many Rust jobs actually. Actually, we just take a look. How much were there? Maybe 8, 9?
The jobs we saw.
Yeah.
Yeah. I think there was
And they weren't like pure Rust developer jobs.
Yeah,
Maybe
it's
like
Go
90%.
Rust or something. Yeah,
So in whole Poland, there are maybe 1 or 2 pure Rust job.
could be. I think I know of 3 companies. So we have like the company I work currently at. It's not pure Rust because we have also like .NET or I think Ruby also. But like I'm specifically in like a Rust position, so I do Rust all day, all night. I think it is like a software house in Wrocław also. And to be fair, I haven't researched more thoroughly, so maybe there's some new company lurking beside the corner.
I believe if you are looking for a new tech job, the direction is United States. Like because the startups, the ecosystem here there is so live and so fresh. It's constantly trying new things, try to be better. It's fucking amazing. Like look at the Go jobs in United States. It's incredible, man. So many of them.
Yeah. But for instance, I also know of one colleague from my work that got recruited into, I think it's like in Denmark, and he's also doing Rust now. So I think if you know some Rust, there's like lots of opportunities for you to choose from. But if you don't know Rust and you want to get started on the market, it's very difficult. I mean, I think the most difficult position is like if you know only Rust and you have no previous experience in any language.
Oh man.
So this is like you are pretty much hardly employable, I think.
Yes.
If you know PHP or maybe C++ and you work for like a few years and now you want to switch to Rust, it's a completely different story.
Yeah.
Because you already know how programming works, so then switching languages is easier task.
And for example, because I know that the companies are looking for professional experience, like the experience you actually use the language in a company. And let's say, for example, you're a senior TypeScript developer and you want to apply for a senior Golang position. You've been making projects with Golang for 2+ years maybe, but no professional experience. What do you think? This guy has a chance?
I think such a person starts a chance. I think because when you see job advertisement that says senior Go, they're probably looking for someone close to being a team leader, or at least someone who can guide other people in writing Go code. And in this case, you wouldn't probably have gotten hired as a senior, but maybe as a regular.
Junior.
Mid, yeah.
Oh,
closer to mid in my head. Because junior is for people who, describes, I think, people who still need to be held by hand, guided in writing code. But if you have written some code already, even if this was different language, you more or less internalize, how code is written.
Yeah.
So even though you say write interface instead of class, or maybe fun instead of fn or stuff, you pick it up very fast.
I get it. Yeah, but it's still problem that the technology you applied, do you used in your first job becomes your destiny. Like you go with that one usually, right? Yeah, it's a bit sad because, to be honest, I don't think you need to master a specific technology that much to be productive. Like if the job includes a PostgreSQL, you don't have to know what is vacuum in PostgreSQL. Probably, you can just set up an ORM and be productive, do some stuff. And I'm not sure if you actually become better while you wait few years, while you spend time with few years with that language. I believe there is a certain threshold, and after that, you don't get better in that language.
Yeah, obviously there are some stuff you can learn by pure chance, like say, some intricacies,
Yeah.
of the programming language or the technology.
Yeah.
And it's with time, if you experiment, so you don't stagnate, you actually do new things in this technology, you will learn its limits, or some caveats you need to know about.
Yeah.
And this is, I think, what makes a senior. So it's a person who, at least, even if doesn't know everything, that maybe knows that there's some things they don't know about that are lurking there waiting to be discovered.
I agree.
So like you have a junior who will say that let's push 1 million terabytes into MongoDB and then worry about consequences. And then you have like people who are like medium or seniors who know that you need to shard the data, maybe split into many different types of databases.
Yeah.
Because if you do it too soon, it might be too late. If you do it too late, it might be very difficult to switch.
Yeah. Definitely. I agree totally. So what you would suggest for a new Rust developer? Or maybe, let's say, not new Rust, but people who have some experience, a few years experience in other backgrounds and want to switch to Rust. How they should find a medium level job?
So I think it's important to first of all think about what do you think of cryptocurrencies. This is obviously like the elephant in the room that some people like them, some people don't.
And most jobs are cryptocurrency jobs.
Not sure if most, but certainly lots. So there's on Reddit, there's r/Rust subreddit there.
Yeah.
And there's like, I think, bi-weekly thread with for employees who look for employees. And I think lots of them is crypto, or at least used to be. I'm not sure nowadays because I'm not looking actively. So first of all, you need to decide, set your mind of if you don't like specific domains. If you like everything, then great for you because it's
or if you like money.
Yeah.
There's also an option.
Yeah, this obviously, if you don't filter your options, it makes it easier to find something.
Yeah.
And as for, there's some example apps you can code. I think it's important to see what the company is actually doing, because since Rust can be used for pretty much everything, from HTTP servers through cryptocurrencies to typical, desktop applications. It's important that when you apply to a job that says that, let's say, there's HTTP servers, microservices, let's say, you can do something like that, for an example application. If you apply for a cryptocurrency job, you would be viewed better if you prepared some cryptocurrency, Merkle tree, whatever.
But I mean, like, should you actually build a project per job? Because that means a lot of projects.
Yeah, this means a lot of projects. I think there's like actually just a few kinds of projects. Yeah, so you can build. So for cryptocurrencies, you can build just one generic Merkle tree, whatever, some algorithm, and you can use it everywhere for your cryptocurrency job positions. I think even building anything is good. So even if you're applying for like cryptocurrency job, to follow the example, I think even having a game in Baby will help you.
Yeah.
Because it's at the end of the day, it's just writing some code. So it doesn't matter if you prepare example of A or B or C, as long as you prove that you can do something.
Yeah.
You can always do something else at your job.
Definitely. So let's finish this part and talk about your projects actually.
Yep.
As far as like we talk, I know that you made 3 separate projects. All of them are really interesting. One is this embedded programming for meteorology.
Yeah.
And the second one is the AI project you did actually. With Rust, you build an AI system. And the third one, I believe the coolest one, the game engine you did.
Yep. So for the AI, I actually have 2 different kinds of projects. Both are described on my blog. So to just shine a light about what happens there. The first one connects genetic algorithms with neural networks. And it's like you have...
What is that? Genetic algorithms with neural networks?
Yes. So to describe first what happens inside the game simulation, then to explain what's going on there. So the simulation, or the game, so to say, is that you have 2D board. And on this board, on this map, you have birds and food. And birds have simple rule to survive. and they survive by eating food. So, and now genetic algorithm is a way to, or maybe before we get into that, let's say about neural networks. So you can code such a single bird with actually writing some function that say discovers the neighborhood of the bird and tells it to fly to the nearest food it's got in its line of sight. But it's more interesting if you, instead of writing the code, tell the computer to write the code. This is where the neural network part comes in. So each bird has one eye. Well, in my case, they have one eye, and from their eye they discover the surroundings. And the brain, so like the function of the bird, is to take the eye and determine what to do next. If to fly straight, fly left, fly with what speed. So this is basically like a pure function from the eyesight into like the motors, so to say. And neural networks help in the sense that the neural network as an input gets the eyesight, so like just like humans would do, I guess. And as the output, the neural networks tells the bird where to fly. And initially, all of the birds start with random brains. So when you have this neural network, it's essentially randomized. It's totally random, and the birds fly in totally random directions. But some of the birds, by pure chance, happen to contain, when you have lots of them, they will happen to contain brain that will kind of steer them towards the food.
I get it.
Just by pure chance.
It's probably random, initial ones, and you kill all of them, take those ones that are lucky, and go with its own genes, right?
Yes.
Isn't it evolutionary algorithms?
Yes, this is a class of evolutionary algorithms.
Nice. In previous episode, we also talked about it, actually.
Oh, that's nice.
Yeah. So you did it yourself?
Yes, this was an idea I had for like 8 years now, and I've coded it finally 2 years ago and prepared, the whole set of blog posts.
Wow. Incredible.
Yes,
so
it was
6 years.
satisfying.
6 years project.
It was actually it was like I wrote some initial sketch 6 years ago in Pascal even, and then I just I haven't had much luck with it on the first try because I probably did some math wrong and wasn't satisfactory enough. So I stashed it to my under the blanket.
Yes.
And then in 2 years ago, I remember that I had a project such as that. I tried to do it again in Rust, in WebAssembly even, and it worked. It was very satisfying. Yeah, I think my first version actually had some bug in the math.
Incredible.
Yes, it was very satisfying to watch the birds. And just to give a hint, what you actually see on the board, how do you know it works, is that you see the birds flying in real time. So it's like you see them flying towards food.
What? You even see the birds in a 3D?
In a 2D, actually could be 3D also, but in my case 2D.
In
you
2D?
see them flying, yeah.
So you see actually each evolutionary step.
Yes.
Nice.
So the simulation goes for like 1 minute. Then after this 1 minute, the simulation, because the game knows which birds it ate the most food, which are like the best candidates to reproduce. So then the genetic algorithm kicks in. It randomizes, treats these birds as parents, creates a new board from scratch, adds some randomness also, but doesn't randomize the whole brain, just some parts to keep the population distinct, and it's run again.
Nice.
And after like 20 steps, which is 20 minutes, but you can speed it up to just like a few seconds because it's 20 minutes only for simulation purposes because you can see it in reality a few seconds. And with each generation, you can see in your own eye that it actually works. And after this 20 steps, you have birds that fly to the food very fast.
Great.
They just see food and...
Do you know this YouTube channel called Code Ballet?
No, this one not.
All the thing the guy does is actually creating evolutionary algorithms to hack the games. And all of them are working so good. It's incredible. Yeah. I wish you would make such a YouTube video, man.
Yes, I was actually considering it, but nowadays I don't have that much time because I'm doing my other project with this rendering engine.
Yeah.
So
maybe I can help you with the editing and everything. Yeah, maybe we can do something together. Yeah, but really cool project. And for this AI model, do you know how many layers and parameters it had?
Yes, because I designed the neural network also. So this was called feed-forward neural network, which is like second to the first most simplest.
So this is the type of neural network, right?
Yes, it's called feed-forward neural network, FFNN. Yep.
Yes.
And the way it works is that you have input layer, which in my case was, the data from the eyes, which was a number saying for each like eye cell, how far the food is from it.
Yes.
So if we imagine that I'm looking at the mic here, then the input to the network would be like, and there's only this mic here. It would be like infinity, I don't know, half a meter, infinity. And the birds had 8 eye cells, I think. So this would be like 8 numbers to the input. Then we have what's called hidden layer.
Yes.
You can have as many hidden layers as you want. I think I had 1 or 2.
So each bird had 8 eye view in a 2D.
Yes. So it was like this plane, and you had like 1 eye cell.
Yes, like this. So you also use geometry and trigonometry, right?
Yes.
To understand what in which field it contains, actually.
Yes, it took me a while to figure out the calculations, because you had like each bird could have differently configured, eye view, and they can also be rotated.
By the way, it has a GitHub?
Yes, it's on GitHub. It's called
Let's check it, man.
Shorelark.
In here, in this Riverside FM, I can share the screen actually.
Oh, that's nice. So we can share my website, because you can also show how it's working, because I have
let's do it.
WebAssembly built of it.
Let's do it. Just check here. I'm checking. All right, share. Nice. So I will right now put something. Okay, we are able to see it.
And you can just write pwy.io.
pwy.io. That's a cool name for a personal website.
Yep, and you can click Learning to Fly.
Learning to fly.
Yeah, anyone. And if you click on the image, it will open the application.
Is this the application?
Yeah.
It's way better than I thought. way better than I thought. So it is running in a terminal, or how it works?
If you open it, it's an HTML canvas. Yep.
It's a really cool project. Wow, is it in real time right now?
Yes, it's in real time.
So in one server somewhere, they always are
in the browser.
In the browser.
Yes, because it's WebAssembly, so it's compiled into.
So in my own machine actually.
Yes, so it's working in here.
And what are those cycles?
Those are brains that happen to be somehow fucked up. Because they are all random in here. This is like the first generation.
Yeah.
So some of them happen to, look for food. Some of them just run around in circles because the brain is like having seizures.
Yeah.
And
so stupid ones.
Yes, stupid ones.
So are they dying when they don't find
Yes,
food?
they will die after a few seconds, when the generation ends, and we sort the birds from the best to the worst.
Wow, right now generation ended, right?
Yes, so it blinked because the generation ended. This is the second generation. It somehow should be
Patryk,
somehow better.
This is the coolest project, one of the coolest projects I saw.
We can speed it up, actually, because the terminal allows you to write comments. And we can run a command called train. And we can run it 20 times to skip 20 generations. I think it was like that. It hangs for a while, and now it's skipped.
So because of you use WebAssembly, right now it is executing Rust code inside my browser.
Yes.
This is one of the coolest projects I saw.
And the coolest part is that...
Now I see that, actually maybe some of them are listening. All the birds are speed up super fast compared to the first generation.
Yeah.
And basically there are some triangles and there are circles. Basically triangles are trying to hit the circles. That's the basic idea. And all the birds have some sort of shield, look like circle.
Yeah, that's a simulation of their eyesight.
Yes. So it displays actually what is the eyesight. It even makes it bolder when some sort of food is actually closer to them.
Yes. So we see what they see. So the green goes from like transparent to fully green, depending on how close they are.
Crazy good. And you definitely should make a YouTube video about it.
Yeah, now that I think about it, it feels like a very nice idea to show off.
Yeah.
And what's best is that we haven't actually taught them to look for the food, because all of what the genetic algorithm does is that we have a scoring function that says which birds we want. So what's best is that we can reverse the scoring function to look for the birds that avoid the food. And we can do it quickly because there's an example in here. I will just copy paste it. Funky scenarios, this one. This will train the birds to, tell the genetic algorithm to choose the birds that only avoid food. And we can also skip ahead 20 generations.
So
they will be
food avoiding birds in 20 generation. Wow, it is like a smart system actually.
Yes, and like I said, the best part is that this feels like magic because the Rust code nowhere it actually codes the behavior of the birds. You will see they don't really avoid all of the food because it depends how the brains are randomized, but you can see the difference in the behavior in here. Certainly.
Wow. It's a really cool project. And you didn't use TensorFlow or anything. You write
it's all from scratch.
Yourself.
Yes, and it's actually very simple. In the blog post, I actually describe all of the math from scratch with drawings and stuff. So I think the blog post took like 10 months to write.
Wow.
Yes.
And how many views you had? Do you have analytic tools?
I think I don't. I do have logs from an Nginx, like from the HTTP server, but I don't really have any cookies or stuff. So it was very popular on Reddit nowadays. So I think not nowadays, but back in the days. So it's nice. I have to repolish it a bit because since it was written about 2 years ago, it uses some older Rust constructs, some older Rust, the older version of Rust.
Yes.
This would be nice to find a way to polish it to the newer Rust.
Yeah. Maybe what I would do is I would add a timer to show what is the generation and how many seconds left to refresh the generation.
Yeah, that's true.
Recreate it.
I mean, you have generation number in the terminal, but you don't know how many remaining steps.
I also really like the design of the site. This green color and blue.
Yes, feels like hacking terminal.
Yeah. It's really beautiful. I didn't know that it's such a beautiful project. It impressed me so much.
Thank you.
So I cannot just look otherwise. I do another place. I want to also check the other project. So let's talk about the other project. Let's first see the GitHub of it.
Oh yeah.
All right. So. Is it in your repository or do you guys have an organization?
It's my
GitHub /
Patryk 27.
Patryk 27 /
You can just open my main site. It's linked in the the pinned repositories.
Nice. Beautiful dog. I met with him, right? With her.
Yeah, that's Hauka.
Yeah, Hauka. So is it Shorelark?
That's the one.
You guys have no, this is learning to fly.
Yes, this is the series of how to write those.
I get it. So if I follow actually your blog post, can I build it myself? Wow.
Yes, that's the goal, that you follow it and you build it yourself.
Incredible.
And this is why it took so long to write, because at the end of when I stopped writing each post, I've gone from the beginning to the end, trying to actually follow the instructions I've written to make sense, to ensure that it makes sense.
Yeah. This deserves a YouTube tutorial for real. And what about the new project you have?
Yes, it's called Strolly. I thought I had it pinned, but I do not right now.
So it's in your project, right?
Yeah, somewhere in there. Oh yeah, at the top.
Strolly. 8 forks. Damn.
Yeah.
2 contributors and 8 forks. Wow. Are those images exactly from your...
Yes, they're not modified more. It's exactly, you can run it locally, and this is exactly what you will see.
Wow. Right now, if I run it locally, would I see this? Really?
Yeah.
Let's go it. The git clone. Alright. Damn. Yeah, due to our upload of the podcast, it's a bit slow. But it's okay.
Yeah. Oh, get it.
So, cargo run that.
Cargo run, release.
Cargo run, release.
Minus release.
Minus release.
And also minus example.
Minus example.
With space between those two.
Minus example.
Demo.
And
space demo.
Space demo.
It will take like
it
5 or so minutes to compile. Oh yeah, I have to run it again. The issue with this error message is that you open VS Code, which try to also download the Rust version, and it sometimes collides with when you run it from terminal.
So in 5 minutes or so, it actually compiles, and we go with it.
Yeah.
This is the first time I'm seeing a Rust project actually compiles for 5 minutes. You know, my projects are so simple. It's like light speed, like 1 millisecond.
Yeah, I would love it if it compiles faster though, but I just don't have. I don't know why.
Yeah. So why it actually compiles? Maybe I can execute it not in VS Code, but in my terminal. Would it help?
If VS Code is already running, we can give it like a minute or two.
Oh, okay. Let's see.
Yep. Yeah, so it takes a while because it requires so much code to display something on the screen.
Yeah. And this project you have is actually a game engine.
Yes. So it's like, game engine is probably a bit too much because this is just the rendering part. So the game engine is like baby. And then Strolly is like just different rendering engine you can plug in to Baby to get different kind of visual output. But for instance, Strolly does not deal with audio because Baby already does audio stuff.
So this image is actually coming from Strolly? This looks incredible, man.
Yes, and what Strolly does is that it simulates how the light bounces off the scene. So for instance, in this case, we have light which is outside on the right side of the map.
Yes.
But even though this light doesn't directly hit the wall on the right side, it's still visible because the light reflects from the ball, from the floor, and lights the rest of the room.
So how did you actually do it? In here I see a door. So at first, let's go step by step. How did you build this environment? Did you guys code it, or do you have some sort of software to put to things and color them?
So this particular map was actually taken from Sketchfab. Sketchfab is a site that has 3D models or 3D maps. So the map itself is not designed by me. The map is taken from Sketchfab. You will see the link in the README if you wanted to explore more. And in this case, what Strolly does is that there's an algorithm called path tracing that simulates, basically renders photorealistic images.
Yes.
And the way path tracing works is that it tracks when you have lights on the scene. It does what the reality does, so it simulates how the photons from the light sources bounce around the scene and color stuff around them. So
you use this algorithm called path tracing?
Yes.
And you take this 3D in some sort of format and execute it in your own software?
Yes.
And how did you actually code it, the light source? And how did you put it to there?
So the way it works is that if we imagine we see the scene we have, and then for each pixel we have some 3D position of where this pixel is, on the scene. So the pixels further away from the camera are in different places on the world than other places. For each pixel, we select some light from the scene, and we do what's called tracing array. So we check if there's any obstacle between the light source and the pixel, the world position of the pixel on the screen.
Here there is the pixel and there is the light source.
Yes.
You guys first calculate what are the pixels that will be affected by this light source. So you guys are actually checking all area, but because of there is a obstacle, it cannot go there, and it's only going down.
Yep.
Then what?
Actually, when it comes to path tracing, then this is the gist of it. So there's also the second issue of what's called indirect lighting. So if we just looked at the light source and the point on the map, then half of the screen, 90% of it, now that I think about it, would be dark, because for instance, all of the light that's in here, it's not visible to the first light source.
Yes.
But at the same time, we wouldn't want it for it to be black, because that's not how light works. Light bounces off around the scene. So what happens is that for each pixel, we also send a ray in a random direction and check if any light reaches that random point. So to be precise, in this case, for instance, even though no light reaches here, some of the directions will say randomly travel to here.
Yeah.
And then the pixel is lighted through this light. So it's like we go through here, randomly, let's say here, and then because this pixel is lighted, the light bounces off and also reflects this part of the scene.
I get it. So
and if you do it multiple enough times with million samples, you will get.
I get it. So when the light actually goes, it's going through a loop of millions of times. Well, maybe not millions, but a few thousands maybe. And there is some sort of mirror here. So it actually mirrors that light to this place. This place probably mirrors to somewhere else, but increasing the brightness, right?
Yes.
And usually if there isn't a mirror, it's going just geometrically. So if it's going with the 45 degree, it goes back with 45 degree.
Yeah, more or less,
right?
yeah.
And you guys coded it yourselves?
Yes.
Wow.
I cannot take all of the credit, because we used a few algorithms that were released, I think 2 and 3 years from NVIDIA, because when you do it, actually the way I said it is that first of all, because this is a real-time graphic engine, we only have about 16 milliseconds to prepare the whole image, because you want to have 60 frames per second, right?
Yes.
So this gives you 16 milliseconds.
Yeah.
And if you only have 16 milliseconds, then you cannot actually trace more than 2 rays per pixel.
Yeah.
Like modern GPU. So if you do, on the other hand, if you trace only 2 pixels to 2 rays per pixel, so the direct light and then one randomly bounced somewhere from the else, then you get a very noisy image. As if you've taken, half of the scene would be dark, because if we go back to this image, let's say that this pixel randomly decided that we shoot here, and we check that no light reaches this directly, so this pixel would be black. But it being black is wrong, because it should be actually average of all of the directions in here, right?
Yes.
So it's not like one ray is correct, it's not like 2 rays are correct, it's like the integral of those all directions is the solution we're looking for. So in practice, to get noise-free image, you would need to shoot about 100 samples for each pixel, and there's no way to do that in a reasonable time.
Yeah.
And there are cool algorithms from NVIDIA from 2 or 3 years ago called Restir, and these algorithms allow you to denoise the image, so to say.
So you guys are using this actually?
Yes, we've coded them from scratch. It actually took me 3 months to understand one of the white papers involved here. It was kind of frustrating, because I'm not a very good mathematician myself.
Yeah.
And those papers are very math oriented, so we have those integrals, some divides, some probability density functions.
But the problem is, you know what you don't know. The thing is, when I look at this project, I don't know what I even don't know. That's the issue. In order to learn the stuff, you need to know the exact things, or maybe in general the theme you don't know. How do you, for example, knew how to represent ray tracing in Rust? How did you actually learn this one?
So it all started before we can check on VS Code to see if it compiles.
But the download process actually failed again.
This time it should work.
Really? You sure?
Yeah, it works.
How this time it worked actually?
So the issue is that VS Code was already downloading the toolchain, and then we were doing it also from the terminal, and it detected that there's a collision. So we needed to wait until the VS Code started.
By the way, do you use VS Code for Rust?
I use Emacs.
Oh yeah, Emacs. you mentioned me last time.
Yeah.
When we met, yeah.
So about
it's the license, guys. Be careful.
It's MIT, so.
Yeah. So it's.
But it turned out very large. If you say open the Strolly shaders project, directory there's like 20 of them, I think.
Oh.
And each shader is like one function that does something on the whole image. So for instance, the atmosphere shader generates the sky, which happens not to be visible on the screenshots, but there's like a sky also.
So it has this copyright Epic Games inclusion.
Right, because this atmosphere algorithm was actually first developed by Epic Games, and we just like transported it to Rust.
Nice. And which language it was written?
Originally, I think it was C++.
Wow. So you guys take it and add actually the copyright MIT license of Epic Games. Is this how you actually take code pieces from other projects?
I think it depends on the license. I think with MIT you should copy the license when you are like doing derivative works.
Yeah.
But the code was basically written in Rust, so.
Yeah, definitely. But it's hell of a job, man. And how did you trust that you will be able to actually finish this project?
I did not.
Yeah, isn't it like scary? Like we may waste months.
Yeah, it took like. Actually, can you open Git and check the first commit here?
Yeah. Or even here, actually. Git log reverse.
Git log, yeah.
Git log -- reverse. Initial comment December 3rd.
2020. Yeah, so
it will be 9 months.
Yeah.
Wow. And how often you guys are coding this?
So now I think there's like commit every now and then. I've got commit coming because I'm rewriting some part of the engine.
Yeah.
It's like actively developed all the time.
And are you guys because I'm curious about how you guys are actually working for this project with your friend. Do you guys make pair programming or how do you actually do it?
Okay, so with this Strolly engine, it happened that I coded most of it, and Jakub is working on like the actual game stuff. So say he was designing an algorithm that takes a map we designed in Blender and chunks it into pieces, so that when you kind of like in Minecraft, so you don't load the whole map at once.
Yes.
And you just see like the chunks next to you. So that's the way we've divided work, so that we do just different things.
So you are doing all those engine in a year yourself?
Basically, yeah.
And how did you learn again? Basically, how you should do it? Like, I see things that makes no sense to me. Frame reprojection, indirect tracing. How do you know that you need to use them?
So it's funny because I initially thought this would be a very simple project, and I wasn't aware that if I had been aware that it will take so much work to get it to work,
yes,
I probably wouldn't have done it.
Yeah.
But I started with like one step at a time. So I wanted to check how to display triangles on the screen, then how to add direct lighting, so like without bouncing off the scene. Then it would be nice to have bouncing off the scene, and it's like all of those are like months of work on their own. But on the other hand, because each of those is like a complete step. So like doing triangles and doing some other stuff, because all of those is like complete step, it's actually pretty nice to code because at all times you have something to see that there's progress.
Yeah. And
out of context, this looks like very random stuff that's happening here, especially with those names like direct seeding. What's that? What's spatial resampling?
Yeah.
But actually in the context is it like adds up to what's happening in here.
Definitely. But I have no idea what's going on in here. But probably like you need to have some sort of guidance, right? Like, did you use one resource to learn about 3D game making?
No, I mean there are there is famously known ray tracing in one weekend.
Ray tracing in one weekend.
Yes.
Let's check it out.
I haven't actually read that one. I think I just know that it exists, and it's like famously proposed.
Tracing in one weekend.
In one weekend, and there's a follow-up called ray tracing for the rest of your life, because there's always.
Maybe. Oh no.
Oh, that's the ray tracing in one weekend.
Wow.
And if you ditch the assumption of doing something in real time, and you can just you want to generate an image in, say, 1 minute instead of 16 milliseconds, then it's a very, very easy job, much easier than what Strolly needs to do to be able to do it real time.
I get it.
So that's why this series is popular, because you don't do it in real time, which makes it very easy.
But still, I mean, it seems to me like pretty hard stuff.
Yeah. I mean, it's nice because it generates pretty images, so you can easily validate if those make sense. And even if the underlying math is complex, the result is very satisfying because you have like this photorealistic result.
Yeah, I'm curious about the source code. So it's C, basically.
Yeah.
Man,
and you can see it's like 10 files, and those 10 files generate you already very pretty images.
Wow. And yeah, probably C is a good way to actually learn this stuff.
Yeah, I mean, nowadays you would do this in shaders, and the shader is like a code that is executed on your GPU, because GPU is better suited for this kind of, per pixel tasks. But C is like very good entry point to understand, the fundamentals.
What is this extension? CC?
Oh shit, I recognize it from somewhere. I'm not sure, to be fair.
Yeah, me neither. Alright, probably your project is now compiling? No. Almost. That's impressive, man. That's impressive. I knew that you are an amazing developer, but man... Hello everyone, this is Baris from Future. Well, I have some bad news for you guys. Not that bad, but meh. While recording the podcast, I don't know what happened, but something went wrong. And somehow Riverside, the podcast recorder that I use, wasn't able to get the video me and Patryk are talking about his project. Well, unfortunately it is not, but my desktop sharing is. So if you actually are interested in the game engine Patryk did, please feel free to watch the video till the end. But eventually we talked about the physics, how we did it, and said goodbye to you guys. Well, so I guess I have to do it alone this time. Goodbye everyone. Thanks a lot for watching. And if you didn't subscribe, you would make me really happy if you would subscribe. Thanks a lot again, and see you on the next one.